Haplor is going to take us on a journey to the sphere of plant breeding.
Take a look at the picture on the slide. What do you think that is? That, ladies and gentlemen, is a cucumber. Crazy, right? I mean, the last time I checked, the cucumbers you can get at the store look nothing like the one on the picture behind me. This is because humans have been breeding plants over hundreds of years to develop certain traits, such as less thorny cucumbers. Actually, plant breeding is more important than ever before. We need to make our plants ready for climate change. But the development of a new breed can take hundreds of iterations and up to 12 years. You can shorten this time period by applying a special breeding technique. However, this special technique takes place on the molecular level, so humans can't tell desired from undesired plants.
Now, why is this a problem? During the plant breeding process, only half of the plants show the desired traits. So if humans select those plants only after 5 months, that means 50% of valuable resources are lost in terms of greenhouse space, fertilizer, water, and manual working time. But what if we could select those plants after 1 month instead of 5? And to do this, we have developed Haplor. To reveal the invisible traits of each plant before human eyes can see it, we envision there to be 3 simple steps in the future. First, we scan the plant with our MRI device. Second, those images are then analyzed with our AI software solution. And then third, those plants without the desired traits can be sorted out 4 months earlier than previously possible.
So now you've seen that the AI algorithm and the MRI scanner is at the core of our solution. However, most of this is still a black box. So we've built this web analytics tool to have a better picture of what goes under the scanner. In the first screen here, we have the most important KPIs highlighted, and you have a quick number of how much you can save by using our solution. If you go deeper into one of the batches, the more recent batches that have been scanned, you can see the total number of plants and also the share of which that have the desired traits. In our case, it's the share of double haploid plants. Now you may wonder, as a lab expert, you may want to go deeper into one of these scans and tell the differences between each of these plants. So for this now, you have a look at the results from our initial experiments. So from this, 6 plants that go into a typical experiment or a typical scan, in our case, 3 of them are double haploid. The second, the fourth, and the fifth plant on the screen have the desired traits, but this might not be clearly evident to you right now. But ideally, once this verification is done, we can move over to the selection process and pick the double haploid plants from the rest.
As of today, we scanned not only 6, but 85 plants. The images clearly reveal the inner structures. However, you, me, and the experts could not see any differences between them. But that's completely normal for the first stage of MRI experiments. We will continue with the scanning sessions to learn more about the previously invisible part of our plants, and we hope to find the underlying differences between them. So let's keep on scanning. Tomorrow, our MRI analytic solution will identify the plants with the desired traits at early stage and at a high throughput rate. 4 months earlier and 66 times faster than today. That means plant breeding laboratories will save half of their greenhouse space, half of the fertilizer and water, and half of the manual working time that was dedicated to the anyways useless plants before. And what do we do with all these resources now? The answer is grow more plants.
Putting these savings into numbers and adding a margin on top results in a revenue per plant of €1. Based on the output of plant breeding laboratories, we come up with a total market of €51 million. Thereof, we want to focus on crops as most research has been done in this field so far. In the beginning, we want to start with 2 leading big European plant laboratories, out of which one was already thankfully our partner during the MPD course. Our revenue is split in 2 streams. On the one hand, a fixed time payment of 300,000 euros for the machine and its setup. On the other hand, there's a recurring fee for software updates and maintenance. This market will continuously grow as further plant types will be addressable by the superior plant breeding technology. Furthermore, the global demand for food will grow by 70% in the coming decades. Now, the 2 most important differentiators are time and throughput. Nowadays, there is microscopical analysis or manual labor, however, only at a late stage. At an early stage, there is chemical analysis, but only at a low throughput. Our solution is both early and with a high throughput, 66 times faster than today. We are Pranav, Ellie, Malte, Miri, and Christian, and this is Haplor. We want to make plant breeding more efficient with less resources and more plants. Thank you, and we are looking forward to welcoming you at our digital booth.